Okay, now let's see the RAM input. For the RAM input, our input R of t equal omega I t ut. This is for the RAM input. And then if we transfer into rs, that means the transfer function of it, which will be omega I divided by s square. So now we apply the steady state error, same formula, limit s tends to 0, s, this is the formula, times this is times, this is not x, times omega I divided by s square. Okay, so now you can see the s and we have s square, so s and s square cancel, and at denominator it will be s. So that what it happened. So this s times with the 1, it will become s plus s g s h s omega I. So now you can see that if we replace the value this s with the 0, then it will become 0. So only this part will remain. So omega I is omega I, s tends to 0, s g of s h of s. Okay, so this part. So this part we can actually define as a k of v. This is another constant. We call it static velocity error constant. This is just a constant. So now we will analyze this part. Okay, kv equal limit s tends to 0, s g of s h of s. So now e of s which will be, that means this one e of s will be omega I divided by kv. For a type 0 system, we can see that sv equal limit s tends to 0. This is the, this part. This is a standard question for the type 0. So now if we have a0, if you replace the value of s with the 0, this limit value here, then you are getting 0. That means kv you are getting 0. If you get kv equals to 0, that means e of s will be omega I divided by 0. It will become infinity. Okay. Then for the type 1 system, if it is a type 1 system, then it will be kv equal limit s tends to 0. Because for the type 1 system, you know that for the type 1 system, this is the standard formula. Okay, here will be s, of course, because it's a power of n equals to 1. In this case, you need to know that power of n equals to 1. Okay, because it's a type 1 system. So now s and this s is we cancel, and if we replace the value of s at all this position, only the k will remain, so it will be only k. So that means e of s will be omega I divided by k. Okay. Then for type 2 system or the higher system, that means type 2 or more than that, what will happen, our kv will be s tends to 0, s divided by s power of n. So because the value of n is now no more 1, it's become 2 or more, so that's the reason we are writing s power of n. So no matter what we are writing here, you remember there will be, because this is our s and the value and the value of n equals to 2, so that means at the denominator there will be always one s, correct? So due to this s, and when we replace the value of s by 0, then it will become infinity, because it will become 0. So that means due to the 0 at the denominator, so it will become infinity. So it means e of s will be omega I divided by infinity, because kv will become your infinity. So now then omega I divided by infinity, that one will give us the 0. Okay. Now for the third type system, we call it the parabolic input. I mean, if the input is a parabolic input, if it's a parabolic input, then r of t equal half alpha I t square ut. This is for the input of, if it's a parabolic, then which will give us r of s equal alpha I divided by s cube. So steady state error will be the same like this, just the method is same, just the calculation is a bit different. Okay, so in this case we are giving another constant which we call it k. It doesn't matter, it could be any constant. So this is our limit, then finally e of s will be alpha I divided by ka, If it's a type 0 system, then you are getting infinity. Okay, and if it is a type 2 system, then it is coming alpha divided by k. If it's a type 3 system, it is coming 0. Okay, e of x is coming 0. So finally we have one summary. You can see that if a type of system 0, 1, 2, 3, if is a step unit, mean the step input, then if type 0 system, then e of s will be a divided by 1 plus k, RAM will be infinity, parallel will be infinity. If it's a time 1 system, this is the one. If it's type 2 system, then this is the summary. Okay, that's all.